A cheap drone that costs under $1,000 is now reaching deep behind the front line and forcing entire logistics routes, buildings, and defensive positions to change the way they operate. Right now, across multiple sectors of the war in Ukraine, a new pattern is emerging. Fixed-wing kamikaze drones like the Molniya are no longer just experimental tools. They are being used at scale to hit targets 20, 30, even up to 50 kilometers behind the line, in areas that were once considered relatively safer compared to the front. The risk is no longer limited to soldiers in trenches or armored vehicles in direct combat. It now extends to supply routes, command points, and rear positions that were never designed to handle constant aerial pressure from low-cost systems. And once those areas become exposed, the entire structure behind the front line starts to feel unstable. But here is where the story takes a turn. Ukraine did not just try to stop this threat. It studied it, took it apart, and built its own version, designed to fly farther, deploy faster, and operate at scale under real battlefield pressure. Stay with us, because this is not only about one type of drone. It is about how both sides are learning, adapting, and turning each other's weapons into something more dangerous. So the real question is no longer who has the better drone. It is who can change faster when the battlefield itself keeps evolving. Russia introduced the Molniya to solve a very specific gap on the battlefield, and that decision is now changing how the war is being fought behind the front line. Before this drone appeared in large numbers, combat in Ukraine followed a pattern that had become familiar over time. Small FPV drones were cheap and widely used, but they could only reach targets very close to the front. Heavier unmanned systems were able to carry more explosive power and operate farther away, yet they were expensive and often reserved for targets that justified the cost. Long-range strike platforms existed as well, but those were designed for deep missions and could not be used constantly without draining valuable resources. This created a middle-distance zone that was difficult to manage. It was too far for low-cost systems to reach reliably, yet not important enough to justify the use of high-value weapons on a daily basis. That space, often around 20 to 30 kilometers behind the line, became a kind of blind spot where movement, storage, and coordination could take place with less pressure compared to the front. The arrival of the Molniya changed that balance in a direct way. Instead of trying to build a complex platform, Russia focused on a simple fixed-wing design that could carry explosives just far enough to hit those middle-range targets. The airframe did not need to be advanced, and the electronics only had to perform basic navigation and control. What mattered was that it could be produced quickly, launched in large numbers, and guided toward areas that were previously harder to reach with cheap tools. This approach gave Russia a new way to apply pressure without relying on costly systems. A unit did not need to call in artillery or wait for a limited number of long-range strikes when a low-cost drone could be sent toward a supply route or a building used for coordination. Over time, repeated attacks like this began to reduce the sense of safety behind the front line. Positions that once felt stable started to look exposed, and every movement carried more risk than before. The strategic effect does not come from a single strike, but from constant disruption. A vehicle may not be destroyed every time, and a structure may not collapse with each impact, yet the pressure forces units to move differently, store equipment in new ways, and spend more time thinking about protection. That slows down operations and creates hesitation, which is often enough to change the outcome of a local engagement. Molniya also reflects a broader shift in thinking. Instead of asking how to build the most advanced drone, the focus moves toward how to fill a gap with something that is good enough and can be used again and again. In that sense, its value is not only in what it hits, but in where it reaches and how often it can be deployed. This raises a question that goes beyond one design. If a low-cost system can extend the battlefield deeper without heavy investment, then the line between front and rear begins to blur. Areas that once supported the fight from a distance are now part of the fight itself, and that change may matter more than any single piece of equipment. So the issue is no longer about one drone entering service. It is about a new layer of pressure that did not exist before, and a new way to challenge space that used to be outside the reach of simple weapons. The danger of the Molniya does not come from advanced technology, but from how precisely it solves a real battlefield problem at a very low cost. This drone is built to reach targets that sit just far enough from the front to avoid constant pressure, yet close enough to influence daily operations. That range allows it to strike supply routes, temporary shelters, and coordination points that are active but not always heavily protected. At the same time, it carries enough explosive power to create real damage, not just a symbolic hit. When this level of reach and impact is combined with a price that allows repeated use, the result becomes much more serious than the design might suggest. The key factor is balance. A system like this does not try to compete with high-end platforms in terms of precision or power. Instead, it offers something more practical. It can be launched often, it can be directed toward different types of targets, and it can keep pressure on areas that were once used to support operations with less risk. That balance between range, effect, and cost turns it into a tool that fits daily combat rather than rare missions. Another important aspect is the variety of payloads it can carry. Different configurations allow it to match different targets, which increases its usefulness across many situations. A fragmentation charge can threaten exposed personnel or light structures. A thermobaric option can create stronger blast effects inside enclosed spaces. An anti-tank mine can be adapted to strike vehicles or fortified positions with heavier impact. This range of payload choices means one platform can be adjusted for multiple roles without needing a completely new design each time. Flexibility also extends beyond what it carries. The same drone concept can be used for different purposes depending on how it is equipped. Some versions focus on direct strike, while others are fitted with cameras and stabilization systems to collect information from the battlefield. This dual-use approach allows operators to switch between attack and observation without relying on separate fleets, which simplifies logistics and increases efficiency. The real impact appears when these factors are applied repeatedly over time. A single strike may not change the situation, but constant pressure forces Ukrainian units to react. Movement becomes more cautious, routes are adjusted, and time is lost in preparation and protection. Supplies may take longer to reach their destination, and coordination becomes harder when positions are no longer considered secure. Even if damage is limited in each case, the accumulated effect begins to shape how operations are planned. This creates a different kind of threat compared to traditional weapons. Instead of focusing on one decisive blow, the Molniya contributes to a steady erosion of stability. It pushes the opponent to spend more effort on defense, to rethink how assets are placed, and to accept that no area is completely safe from low-cost aerial attack. That shift matters because it affects not only physical damage but also decision-making under pressure. Over time, this approach changes the role of drones in the conflict. They are no longer used only to support ground forces or assist in specific tasks. They become a constant presence that influences every layer of the battlefield, from the front line to the areas behind it. The focus moves away from single high-value strikes and toward continuous disruption that shapes behavior and limits options. This is why the Molniya stands out despite its simple design. It proves that effectiveness does not always depend on advanced systems. Sometimes the most important factor is whether a tool fits the problem it is meant to solve. And in this case, a low-cost solution is enough to create pressure across a wide area, forcing changes that go far beyond the moment of impact. Ukraine did not respond to the Molniya by only trying to stop it, but by studying it closely and building a more practical version that fits its own way of fighting. When these drones began to appear on the battlefield, Ukrainian units quickly collected damaged or captured examples and sent them for analysis. Engineers focused on how the airframe was built, how the control systems worked, and where failures were most likely to happen. This process was not about copying every detail, but about understanding which parts mattered and which parts created risk during real operations. The first insight came from the structure itself. The original design relied on simple materials and basic assembly methods, which made production easy, but also introduced weaknesses under stress. Ukrainian teams adjusted these areas by improving how parts were connected and by using components that could handle wider temperature changes and repeated use. This did not turn the drone into a high-end system, but it increased reliability, which is far more important in a combat environment where each launch window may be short and conditions are rarely ideal. Another change focused on standardization. Instead of allowing each unit to be slightly different depending on available parts, Ukrainian engineers worked to make connectors and internal layouts more consistent. This allowed crews in the field to replace damaged sections faster and reduce the chance of errors during assembly. When equipment can be repaired quickly and predictably, it stays in use longer and supports a higher tempo of operations. The most important shift came in how the drone is launched. The earlier method required careful coordination between several operators, which created a point of failure when timing was tight or when pressure was high. Ukraine moved toward a more automated process where key flight parameters are entered in advance, and the system handles the takeoff sequence with minimal human input. This change removes a layer of complexity and allows smaller teams to operate the drone with greater confidence. These improvements came together in the form of the Blyskavka. It is not designed to outperform every other system in speed or payload, but to perform its role consistently under real battlefield conditions. That means it can be prepared quickly, launched with fewer mistakes, and used in larger numbers without requiring highly specialized crews. In practice, this approach fits better with a conflict where time, resources, and manpower are all under constant pressure. The goal behind this development is clear. Ukraine is not trying to create the most advanced drone in this category, but the most usable one. A platform that works every time and can be produced in steady batches becomes more valuable than one that performs slightly better on paper, but fails more often in the field. This focus on reliability over perfection reflects a broader shift in thinking about how technology should be used in war. This process also shows how quickly adaptation can take place. Instead of waiting for long development cycles, feedback from the front is turned into changes within a short period. As a result, Ukraine moves from reacting to a threat toward controlling the same type of capability. The drone is no longer something that only needs to be defended against. It becomes a tool that can be used in return, with adjustments that make it better suited for local needs and conditions. This marks a significant transition because it shows that the balance is not fixed by who introduces a technology first, but by who can refine it faster and apply it more effectively. The real shift in this phase of the war is not just about one drone model, but about how low-cost fixed-wing systems are extending their reach while accepting clear limits in exchange for scale and efficiency. These drones are not built to do everything. They are designed with a narrow purpose, which is to fly out to a medium distance and strike a target with enough force to disrupt operations. Unlike quadcopters, they cannot hover, adjust direction quickly, or chase moving targets once the attack path is set. Weather also plays a larger role, and thick fog or strong wind can delay or even cancel missions entirely. This means timing becomes critical, and operators often wait for the right window before launch. Despite these constraints, the concept still works because the mission itself does not require high flexibility. These drones are not trying to replace close-range precision tools. They are filling a different role that sits between short-range attacks and deep strike systems. In that space, the ability to reach far enough and hit with consistency matters more than maneuverability. This is where the relay drone becomes important, not as a complex upgrade, but as a simple extension of control. Instead of relying on a direct signal that fades with distance, operators use an intermediate platform to carry the connection forward. This creates a link that allows the strike drone to travel farther while still receiving commands and sending back basic data. The system does not need advanced infrastructure, and it avoids the high cost that usually comes with extended range operations. The effect is a quiet expansion of the battlefield. Targets that were once just outside the reach of low-cost systems are now within range. This includes supply routes, staging points, and support positions that operate behind the line but remain active throughout the day. As more of these areas fall under potential threat, the difference between front and rear begins to fade. To understand why this matters, it helps to compare roles rather than technology. A heavy drone platform can hover, adjust mid-flight, and return for reuse, but it requires trained crews, stable launch conditions, and expensive equipment. That type of system is powerful, yet it cannot be used freely without considering cost and availability. By contrast, a fixed-wing strike drone operates more like a simple delivery tool. A small team can prepare it quickly and launch it from a basic position with minimal setup. Its purpose is to reach a point, deliver its payload, and apply pressure at a distance that was previously harder to touch with cheap systems. Over time, that repetition becomes more important than individual performance. A single strike may not decide anything, but a steady flow of attacks forces constant adjustment from the other side. Another important point is that these drones are not meant to fight each other in the air. Their role is surface-to-surface attack, which means they rely on separate systems for defense. This creates a clear division between offensive tools and defensive measures, and it pushes both sides to develop solutions that go beyond a single platform. This leads to a deeper question about the direction of the conflict. If range can be extended through low-cost solutions, and if those solutions can be used again and again without heavy investment, then the meaning of distance starts to change. Areas that once sat just outside regular threat may no longer stay that way for long. Ukraine's response to this expanding drone threat is not centered on a single weapon, but on building a layered system that reshapes how survival and movement are managed across the battlefield. The first layer begins even before an attack takes place, through route awareness and planning. Units no longer move along open paths without preparation, and reconnaissance now focuses on identifying where drone exposure is highest. This includes tracking patterns of previous strikes, observing likely approach corridors, and adjusting movement schedules to reduce risk. Travel itself becomes a controlled activity rather than a routine action. Electronic warfare forms the next line of defense, aiming to disrupt incoming drones before they reach their target. By interfering with control signals, these systems can reduce accuracy or force the drone to lose its path. This does not guarantee a stop, but it creates instability in the attack process and increases the chance that the strike will fail before impact. If a drone passes through that layer, it enters the range of small fire teams positioned near key locations. These teams are trained to react quickly and engage low-flying targets with adapted weapons. Their role is immediate and focused, providing a direct response when automated systems are not enough. This human element adds flexibility at close range, where fast decisions can still make a difference. Beyond active defense, physical protection has become a defining feature of the battlefield. Roads, supply routes, and command areas are now covered with layers of netting designed to intercept or disrupt incoming drones. These measures may appear simple, but their effect is significant. A drone that relies on a low-altitude approach must now deal with obstacles that reduce its ability to reach the intended target. Even when a strike still occurs, the impact is often less effective. Over time, these physical defenses change how attacks are planned and how targets are selected. Another layer comes from interceptor drones, which introduce a direct response in the air. These systems are designed to engage incoming threats before they reach ground level, either by colliding with them or by disabling them with small payloads. The airspace close to the ground becomes an active zone of contest rather than a one-sided threat environment. When all of these layers are combined, they form a network that operates continuously rather than a set of isolated measures. Each part increases the chances of stopping an incoming threat, and together, they create a structure that can absorb repeated pressure. Even if one element fails, another may succeed, which makes the system more resilient over time. The effect of this system extends beyond protection and begins to reshape behavior. Movement slows down as units avoid exposure, routes become more complex, and coordination requires more planning. Tasks that once took minutes now take longer, because every step must consider the possibility of detection and attack. This introduces friction into daily operations, which can influence outcomes without a single decisive strike. At a larger level, the battlefield itself is being reorganized. Infrastructure is adapted to reduce vulnerability, and space is structured around minimizing risk from above. The distinction between safe and dangerous areas becomes less clear, as threats can appear in locations that were once outside constant pressure. What Ukraine is building is more than a collection of defensive tools. And as this system continues to develop, it raises a larger question about the future of war. If survival depends on layered adaptation rather than single solutions, then control may belong to the side that can keep that system working under constant pressure. What we are seeing right now may look like a small shift, but it is quietly changing the rules of war in a way that is hard to ignore. A drone that costs less than a single artillery shell is now reaching deep into areas that were once considered relatively safe, and it is forcing both sides to rethink how they move, how they hide, and how they fight. Russia found a way to fill a gap with something simple and scalable. Ukraine did not just react, it studied that idea, improved it, and turned it into a system that can both strike and defend at the same time. Now the battlefield is no longer defined only by firepower. It is shaped by how fast each side can learn, adjust, and return with something more effective. Every new design creates a response, and every response leads to another round of change. If low-cost systems can keep expanding their reach while staying easy to produce, then the advantage may belong to the side that can adapt faster under pressure and keep that cycle moving without breaking. Can this cycle continue to speed up, or will one side find a way to slow it down and take control of the pace? Drop your thoughts in the comments, and if you want to follow how modern warfare is evolving in real time, make sure to like, share, and subscribe to Military Force.